In this question, we are interested in calculating the integral of square root of 3 minus 2x minus x squared. So first of all, let us go back to algebra and complete the square so we can recognize the pattern. Let us complete the square to recognize pattern. So then we can decide which method we can use. First of all, here you have 3 minus 2x minus x squared. You can factor out negative sign and you can write it as x squared minus 2x, x squared plus 2x minus 3. So let's close up the parenthesis. Now going back to algebra, from algebra, remember that if you have a squared plus 2ab plus b squared, this guy can be written as a plus b to the second power. So what do we see here? We see that we have x squared plus 2x. So if you had 1, so if there was a 1 here, you could use this part and write it as x plus 1 to the second power, but there is no 1, so we cannot just write 1. We have to add and subtract 1 at the same time to balance this, otherwise our work is wrong. So now I'm taking these 3 terms and I write it as x plus 1 to the second power, and I have to add negative 1 down here. So go back to your 3 minus 2x minus x squared, which in turn is minus parenthesis. So far you have x plus 1 to the second power, x plus 1 to the second power. You added negative 1, you have negative 3, so you must end up with negative 4. So negative 1 minus 3. Let me close this up, move this down here. So we have enough space. So this guy is equal to minus, open parenthesis. Here you have x plus 1 to the second power minus 4. Okay. And close up the parenthesis. You can distribute the negative sign. This guy is nothing but 4 minus x plus 1 to the second power. So we just completed the square, everybody. Okay. Very good. Let us go back to our integral. With all of these calculations, with using, completing the square, our integral becomes the integral of square root of 4 minus x plus 1 to the second power dx. Well, okay. How do I recognize the type? Recall that. In general, if you have square root of a squared minus u squared, you can use trig substitution of u to be a sine of theta. So this is the substitution that you're going to use because of the pattern of square root of a squared minus u squared. U can be written as a times sine theta. But what is u here? Well, u is a linear term. U in this case is equal to the quantity inside the parentheses, or x plus 1. So x plus 1 is equal to a sine theta, then dx, we use different color for this one. So x plus 1 is equal to a sine theta. And then dx is equal to a cosine theta d theta. But what is a? A is equal to 2. So here we go. X plus 1 is equal to 2 times sine theta. And dx is equal to 2 cosine theta d theta. Now substitute everything in the integral, simplify as much as you can to see what you can do. So this integral is equal to the integral of square root of 4 minus x plus 1 is 2 sine theta. So here you have 2 sine theta to the second power times dx, but my dx is equal to 2 cosine theta d theta. Okay, it's not that bad. This guy is equal to the integral of square root of 4 minus 4 sine squared of theta, and my d theta is 2 cosine theta d theta. Nothing complicated here. We can factor out 4. So you get the integral of square root of 4 parenthesis 1 minus sine squared of theta. Then you have 2 cosine theta d theta. Very good. This integral can be written as the integral of square root of 4 times square root of 1 minus sine squared theta times 2 cosine theta d theta. Very good. So let's continue. We're just using algebra and pre-calculus stuff. So you have 2 times square root of 1 minus sine squared. Remember that from pre-calculus, sine squared of alpha plus cosine squared of alpha is equal to 1. So 1 minus sine squared of alpha is equal to cosine squared of alpha. Alpha can be anything. So wherever you see 1 minus sine squared, you're going to use cosine squared. So inside your radical, you get cosine squared of theta multiplied by 2 cosine theta d theta. In terms, it is equal to, you have 2 and another 2, you get 4 integral of the integral of square root of cosine squared. This is just cosine itself. So you end up with cosine theta, and you have another cosine. Just copy this guy down. And then when you multiply cosine by cosine, you get cosine squared. So you have 4 integral of cosine squared of theta d theta. Now, as we mentioned before, use the property of cosine squared of theta, which is 1 plus cosine 2 theta divided by 2. Plug that in and complete this integral. So you have 4, the integral of 1 plus cosine 2 theta divided by 2 d theta, which can be written as, well, you can simplify 4 and 2, you get 2 integral of d theta plus 2 integral of cosine 2 theta d theta. The integral of d theta is theta, so you have 2 theta. For this integral, as we mentioned before, let u be 2 theta, du is 2 d theta, so you have du. You're not worried about anything here. You get the integral of cosine u, which is sine u. So you end up with plus sine of 2 theta plus constant of integration. We are not done yet, everybody. Why is that? If we go back up, we know that our integral is in x. So we have to write everything in terms of x. So let us take this u sub that we used here x plus 1 is equal to 2 sine theta. We're going to use this and the right triangle and find the value for theta and find the value for sine 2 theta and continue this process. Perfect. So what do we have here? From this relation that 2 sine theta is equal to x plus 1 divided by 2 is equal to sine theta. What's the meaning of that? It means that theta is arc sine of x plus 1 divided by 2, which goes here. For sine 2 theta, this guy can be written as 2 sine theta cosine theta. So let me rewrite everything down here to avoid any confusion. So far we have 2 times theta, which is 2 times arc sine of x plus 1 divided by 2. This 2 is on the denominator of x plus 1. You cannot cancel out 2 and 2. Plus sine 2 theta can be written as 2 sine theta cosine theta plus c. So far we know that, hey, sine theta is x plus 1 divided by 2. I'm going to plug that in here. So 1 by 1, we are getting rid of all the thetas. We have 2 times arc sine of x plus 1 over 2 plus 2 times sine theta, which is x plus 1 over 2. But what is cosine theta? I don't have any value for my cosine. To find cosine, we're going to use right triangle. From the right triangle and Pythagorean theorem, we can figure out what cosine theta should be. This is your theta here. This is the definition of sine. Sine is x plus 1 divided by 2. So you have x plus 1 on one side in front of theta, and the hypotenuse is equal to 2. So basically, what your length here is 2 squared, which is 4, minus x plus 1 to the second power. So cosine theta is equal to square root of 4 minus x plus 1 to the second divided by 2. Just need to substitute this guy here. So your integral is 2 times arc sine of x plus 1 divided by 2. You can cancel out these two, plus x plus 1 times square root of 4 minus x plus 1 to the second divided by 2 plus constant of integration. That's how we calculate the integral using trig substitution. So to summarize what we did, let us go back up here. We had the integral of square root of 3 minus 2x minus x squared dx. To recognize the pattern and use a correct method, we completed this square. To complete this square, we are going back to algebra. The algebra says, hey, as long as you have a squared plus 2ab plus b squared, you can write it in compact form, a plus b squared. You have x squared plus 2x. What we did, we factor out negative sign. We end up with x squared plus 2x minus 3. We have x squared plus 2x, but the constant 1 is missing. So I'm adding and subtracting the constant 1. So I can take these 3 terms and use algebra to write this in compact form, x plus 1 to the second power. And I'm copying down my negative 1 here. Then I take everything and move it back inside the parentheses. So I have a negative sign in front, parenthesis x plus 1 to the second minus 1, and it also has a negative 1. Now, if you combine negative 1 and negative 3, you get negative 4. If you distribute negative sign, you get 4 minus x plus 1 to the second. So this quantity inside your radical can be written as 4 minus x plus 1 to the second power. Remember trig substitution patterns. If we have square root of a squared minus u squared, a good substitution is u equals to a sine theta. But our u here is a little bit more complicated. It's not just x, it is x plus 1. So your u is a linear term, x plus 1. X plus 1 is a sine theta, but what is a? A is 2, because a squared is equal to 4. So x plus 1 is equal to 2 sine theta. Dx is equal to 2 cosine theta d theta. Substitute everything and then simplify as much as you can. You get the integral of 4 cosine theta to the second power. To calculate the integral of cosine squared, you're using pre-calculus half angle. Cosine squared of theta is 1 plus cosine 2 theta divided by 2. Well, this makes our calculation much more easier. You can separate the integral into the summation of two integrals, 2 integral of d theta and 2 integral of cosine 2 theta d theta. For this integral, use u sub, u is 2 theta, du must be 2 d theta, you already have it. So the integral becomes 2 theta plus sine 2 theta, which in turn can be written as 2 sine theta cosine theta. We rewrite everything, we break down everything into smaller pieces because we want to use trig substitution at the end, and having a right triangle help us to identify the value for cosine. So since x plus 1 is equal to 2 sine theta, x plus 1 divided by 2 is sine, or theta is arc sine or inverse sine of x plus 1 divided by 2. You write it in terms of in substitution for theta, and using right triangle, you have your sine theta, cosine theta, substitute everything, and this is your integral.